Unit 2 has us looking at 1 and 2-dimensional measurement. So we're looking at finding area and perimeter, lengths and areas. So I'm going through the get ready portion here just to go over a few of the symbols, make sure we recall what they are. So here I have a rectangle set up. When you have a square set up at the intersection of two lines, that just means that the two lines meet at a right or 90-degree angle. So all these angles are right angles. If you see the matching dashes, here I have 2, here I have 1. Those dashes just mean that the lines are the same size. So 1 dash, any line with 1 dash is the same size as any other line with 1 dash. Any line with 2 dashes is the same with any line with 2 dashes. You can have 3, 4, however many dashes that you need. But all that means is that they're the same size. So reviewing a little bit of the concepts, we have perimeter. It's just the distance around an object. And the simplest way of working with it in any straight line shape is just to add all the sides up. So in general, if you can't remember a formula or anything, or in the case of some shapes that don't really have a formula because they're misshapen, they're not regular polygons, then you would just add all the sides up. Certain shapes that we know do have certain formulas that we can use. And then the circle, being a special type of shape, has a perimeter which is called a circumference. So we use the term circumference when talking about the perimeter of a circle. Some examples. We wanted to determine the perimeter of each shape here. We have a rectangle here. Both these sides would be 3 meters. Because of the single tick, both these sides would be 4 meters. The formula for the perimeter of a rectangle is P equals 2L plus 2W, 2 lengths plus 2 widths. You may also see it as P equals 2L plus W. I always write my L and W in cursive just because the L doesn't look like a 1 then. But either way, it's the same. It's just, there's 2 lengths that need to be added and 2 widths that need to be added. Does it matter which number is length and which number is width? No. So if this is the width of the rectangle because that's how you see it, when I turn the rectangle this way, then this would be the width. The length and width don't matter which side, which you call which you label which, as long as one side is the length, one side's the width. In either case, we have 2 times 3 plus 2 times 4. And that'll give us 6 plus 8, which totals out to 14. And in this case, meters. And in the last step, you should always put your units at the end. In the case of perimeter, it'll just be meters. In the next case, what we have is another rectangle, except it's a special type of rectangle known as a square. In the case of a square, all the sides are the same length, but it's still a rectangle because it fits the definition of a rectangle. To find the area, the perimeter of a square, you could use the regular rectangle formula, or you can do the perimeter equals 4 times the side length, which is just 4 times 2, or 8 centimeters in this case. And if you couldn't remember the formula for whatever reason, you just add up all the sides. 2 plus 2 plus 2 plus 2 is 8. So there's some examples of working with perimeter of rectangular shapes. Some additional shapes here. I have a triangle, I have another triangle, and then 2 circles. In the case of the triangles, the formula is add up all 3 sides. There's not really a formal formula. You might see A plus B plus C sometimes, but in general, you're just adding up all the sides. So the perimeter of a triangle, in this case, that little single tick means feet. So 6 feet plus 3 feet plus 8 feet 6 plus 8 is 9. 9 plus 8 is 17. The perimeter is 17 feet. In the next case, we have another triangle. In this case, this was a right-angled triangle because there's a right angle in it. All three sides are different, which means it's scalene. In this case, we have an isosceles triangle. What's special about an isosceles triangle is the two sides will be equal and the two angles will be equal as well. In this case, we have 4 and 5, so this side here would also be 4, and that double tick means inches. And I know we usually learn metric, but we often use feet and inches, especially in terms of heights and lengths, and if we're doing construction, so it's important to know those as well. So we'll use them, I'll throw them in there as well as our meters and centimeters and such. So all we're doing again, adding up all the sides. We have the perimeter being 4 plus 4 plus 5, which totals out 8 is 4 and 4. 8 plus 5 is going to give us 13 inches. And there is our triangles. Now, in the terms of circles, they're a little different. The perimeter of a circle is based on pi. Remember pi, which we write like this, termed pi, P-I, not P-I-E. Pi is equal to 3.14. There's a whole bunch of other numbers in there. Actually, it as far as we know, it does not stop. It continues forever. It's what's called an irrational number, and there's decimals that will continue indefinitely. But 3.14 in most cases will give us a fairly accurate answer. If you do have a pi button on your calculator, feel free to use it. You will get slightly different answers, but in most cases, 3.14 should be fine. So in the case of a circle, the perimeter of a circle, known as the circumference, can be done with the formula pi times the diameter. And remember, the diameter is the distance across a circle. So it's just 3.14 times 6 in this case. And in that case, we have 18 and a bit. 3.14 times 6 is 18.84. 18.84 meters in this case. Now, in the next case, I don't have, this should be labeled as F as well. We don't have a diameter. We only have the radius. The diameter is the longest distance across a circle. So if touching 2 points on a circle, it's the longest distance. Going through the center. A radius is the distance from the center to any point on the outside of a circle. And so in this case, it's half of the diameter. So what we need to do here is do 2 pi r. 2r, the 2r portion, and the order doesn't technically matter. It just looks better when we write 2 pi r, and that's how we say it. 2 pi r, 2r, 2 radiuses make 1 diameter. So these formulas are equivalent. Anyways, we have 2 times 3.14 times the radius of 9, in this case millimeters. So we have 6.28 times 9 equals 56.52 millimeters around that circle. So that's perimeter, straight line measurements, or this would be the measurement if you cut that circle open and straightened it out. The next type of measurement we're going to look at is area. Area is the number of square units that cover a shape. So in the case of this square here, it's a 3 by 3 square, so it's 9 square units. There's a total of 9 units, 3 by 3. So we're actually thinking of area. When you think of area, you're thinking of how many squares will fill that space. This even works with circles or any other shape. How many squares? So this square pattern here, how many fit in there? The problem is it's hard to count when we don't have a rectangular type of shape because the squares don't fit together nicely. So we use formulas. So we're going to use some formulas, find the areas of a few different shapes. In the first case here, we got a rectangle and a square, a couple triangles next, and then some circles, same as the perimeters. Area equals length times width. We multiply the length, we multiply by the width, and we will get the area. We have 7 times 8 in this case. And so our area equals 56, and it's meters squared. So this would be broken up into 8. 1, 2, 3, 4, 5, 6. I think they got 8 there, maybe one more. 8, and then you'd break it up into 7 parts, and then there'd be 56 of those that each square would be 1 meter in size. In terms of a square, it's just a rectangle. So again, the area is equal to the length times the width, or because the length and width are the same, we can just square it. That's what we call a square. We can do 5 to the power of 2, 5 squared, which means 5 times 5, which is equal to 25. And in this case, it's centimeters squared. And we do need to put the square at the end of the units. It is not a measure of length, it's a measure of how many squares that we use to make it up and make up the shape. In terms of triangles, triangles can be made into rectangles. Triangles can be made are basically half rectangles. So both these triangles are essentially rectangles that have half them cut off. So when we're calculating these ones, what we can do is do half the length times the width. So area equals 1/2 length times width, or base times height you might use. The terminology doesn't actually matter. Length, width, base, height, it doesn't matter as long as you're multiplying the two dimensions together. You can call them banana and apple. Doesn't matter. As long as you're multiplying two things together, the two side lengths, we're good. So we have 1/2 times 30 times 40. How could you do that in your calculator? Two ways. One, if you recognize that 1/2 is 0.5, you just type 0.5 times 30 times 40. Or, because, like we said in the last unit, these are just fractions, are just division, we can do 1 divided by 2 times 30 times 40. So if I do 1 divided by 2 times 30 times 40, I'm going to get 600, and in this case, it's square feet. And now when we write square feet, instead of using the little tick, we use SQ for square and then FT for feet. Or you could write feet squared. We don't put the tick squared because it looks like 12. So either one of those options is fine for that. In the next case here, we have inches, 7 inches tall, 5 inches wide. So area equals 1/2 7 times 5. And when we tabulate that one, we're going to get 17.5, I believe. Yep, 17.5. 17.5 square inches or inches squared, however you wish to write it. And again, you could write it SQIN as well, your preference. So there's the triangles. Now circles. Circles again, go back to using pi. And in this case, it is pi r squared. So the area of a circle is pi r squared. We multiply the radius by itself. And we do that to get the units squared. If you go back here in any of these, this is 7 meters, m times m. M times m is the same. We have meters times meters. That's equal to meters squared. And again, and that dot there means multiplication. I use it rather than x so we don't get confused. So m times m, meters squared. Here we had feet times feet, so feet squared. Inches times inches, inches squared. So here we'll have 3.14 times 4 centimeters, and because it's squared, 4 centimeters times 4 centimeters, which would give us our centimeters squared that we need. So 3.14 times 4 squared is going to give us 50.24 centimeters squared. And there's our units squared. In the case of the next one, I'm given the diameter. I can't calculate the diameter or use the diameter in the formula, not like the perimeter or circumference. So I have to use pi r squared again. The diameter, remember, is twice the width or twice the length of the radius, so we just divide it by 2. So area equals 3.14 times 6 squared. And 3.14 times 6 squared is going to give us 113.04, and that will be square feet. So there's area and perimeter. I know this one's dragging on long. We got one more thing to go, and that is squares and square roots and the concept of them, because they're important to know and really understand the visualization of this. So here I got 3 squared. 3 squared is 3 times 3, or 9. It visually you should be able to picture in your head when you hear 3 squared, a square that is 3 by 3. 2 squared, you should picture a square that's 2 by 2. So you should actually picture a square. Squares are related to the areas of a square. We're really looking at an area of a square. When we're working with the term square, when we square a number, it's to the power of 2. You can also cube a number or put a number to the power of 4 or 5 or 6 or 7 or 8. But in terms of squares and roots, squares, we're thinking of the actual shape of square. So it's like asking, what is the area of a square with a side length of 3, of 2, of 1? To take the square root of a number, which is the opposite of squaring. So just like adding is the opposite of subtracting, and multiplying is the opposite of dividing, taking the square root is the opposite of squaring a number. So to take the square root of a number, it's just like finding the side length of a square with an area of whatever. So in the case of the square root of 9, what side length will we have if we have a square that has an area of 9? Well, the side length will be 1, 2, 3. So square root of 9 is equal to 3. As 3 times 3 equals 9. Now, radical, why did I put that there? The actual term for the square root sign is a radical. It's only we only call it square root because there's nothing put right in here in this little spot, because it actually changes. It becomes a cubed root. When there's a 3 in there or a 4, we generally just don't write the 2, but this is called a radical as a proper terminology. All right, so we're just going to square and square root some numbers as noted here. So we got 1 squared, 1 times 1. It's just 1. 12 squared, 12 times 12. That's 144. 7 squared, 7 times 7. It's 49. Okay. These are good numbers to memorize. Your perfect squares up to 12, very, very useful. If you can memorize those, that would be awesome. All right, these other ones might be a little tougher. You can use your calculator. You press the square root button on your calculator and then type in the number. In most cases, I think most calculators do that that way. But the square root of 196, that is 14 times 14. Square root of 10,000. 100 times 100. 100 hundreds makes 10,000. And 900 squared. Well, or square root of 900, is 30 squared. So square root of 900 is 30. So there's your squares and square roots, your areas and perimeters. And that's it.